1. Photovoltaic Ray Inspection. Check the components for damage or obvious deformation. Check the MC4 connector between components for looseness and virtual connection. Check whether the photovoltaic resistance string connecting wire is loose or not. Check whether the photovoltaic cable is broken. And filling the inspection results in the form. 2. Inspect the inverter. Check whether the inverter appearance is intact without corrosion, deformation, paint falling, etc. Check whether the inverter is installed firmly and reliably. Check whether the electrical connection of the inverter is firm. Check whether the inverter works normally and whether there is alarm. Press the Enter key on the LCD screen of the inverter. Select Information. Press Enter key. Then press the -sign or plus key to view the corresponding data, and record the inspection results and operating parameters in the table. 3. Patrol inspection of grid-connected distribution box. Check whether the appearance of the distribution box is intact, without corrosion, deformation, paint falling, etc. Check whether the distribution box is installed firmly and reliably. Check whether the electrical connection of the distribution box is firm, no looseness. Check whether the photovoltaic special circuit breaker trips. Check whether the AC lightning arrestor fails, and filling the inspection results in the form. 2. Use appropriate tools to troubleshoot the fault points. Find out the cause of the fault. Return the power station to normal operation. Record the cause of the failure in Table 5.2. At the same time, record the operation of the power station in Table 5.3, and save the screenshot of the operation data of the power station. First, according to the operation duty record form, and the inspection record form to record the results. It is known that the special circuit breaker for grid connection trips. Failure of AC lightning arrestor. DC lightning arrestor is normal. The communication of combiner box is normal. Inverter communication is normal. Meter communication is normal. Then select the AC voltage gear of the clamp meter to measure the port voltage on the special circuit breaker for grid connection. Displayed as 116.4 volts. It is consistent with the value of monitoring background. Description: under voltage tripping of special circuit breaker for grid connection. In the training management terminal software troubleshooting interface, select and successively select a fault cause to the distribution box. Over voltage tripping of grid connected circuit breaker. Failure of AC lightning arrestor. The communication line is normal. And click Submit. Select Inverter. Select a fault cause in sequence. The communication line is normal and click Submit. Select Combiner box. Select a fault cause in sequence. DC lightning arrestor is normal. The communication line is normal and click Submit. Then select the DC voltage gear of the pincer meter. Measure PV1 in the combiner box in sequence. PV to PV3. Lower voltage of PV4 string circuit DC fuse. The displayed voltage is 36 volts. 0 volts, 0 volts, 73 volts. It indicates that the circuit of string circuit 1 is normal, but the corresponding component 1 or component 2 is faulty. String circuit 2 and 3. There may be an open circuit or short circuit in the circuit, or the corresponding photovoltaic module 3457 is faulty. String circuit 4 line is normal, and the corresponding components 1 and 2 are normal. Then disconnect the main DC output circuit breaker in the combiner box. Positive and negative fuses of isolated string circuit 2 and 3. Use the buzzer gear of the pincers. Measure between the positive and negative poles of string circuit 2 and 3, whether it is connected or displayed. There is no buzzer between the positive and negative wires of string circuit 2. The buzzer sounds between the positive and negative wires of string circuit 3. Description: there is no short circuit in string circuit 2. There is a short circuit in string circuit 3. Simultaneously measure the positive pole of string circuit 2, on off of both ends of negative wire. The result shows that I don't want to explain the circuit 2. In the training management terminal software troubleshooting interface, select resistance string circuit. Select a fault cause in sequence. String circuit 1 is normal. String circuit 2 open circuit. String circuit 3 short circuit. String circuit 3 is normal and click Submit. Finally, disconnect all connecting wires of components 1 to 6. Components 7 to 8 are normal. Use the DC voltage gear of the pincer meter. Measure the open circuit voltage of components 1 to 6. Display result 36 volts. 0 volts 36 volts, 4.8 volts 36 volts, 30.5 volts. In the training management terminal software troubleshooting interface, select components. Select a fault cause in sequence. Component 1 normal. Component 2 internal open circuit. Component 3 is normal. Component 4 diode breakdown. Component 5 is normal. Part of assembly 6 is damaged. Component 7 is normal. Component 8 is normal. Then click Submit. After troubleshooting, the system resumes normal power generation. Wait for the background data of student monitoring to refresh. Fill in coding to table 5.3 and save the screenshot. Click Submit after completing the task. Tidy up the working gas tools and clean up the sanitation of the station. After completion, raise your hand to the invigilator. Waiting for the invigilator's instruction.